Okay, for example 3, we are actually given one of our function values and we're going to work backwards in order to find the missing side and all the rest of our trig function values. All right, so first thing you got to do is you got to turn your function value into a fraction. If you remember what we did in example 1, all of our answers that we found were fractions. They were created by taking 2 out of the 3 sides of your triangle and forming a fraction. So we need to turn 2.5 back into a fraction, and that's going to give us 2 sides of our triangle. So 2.5 is 2.5. Let's see where, I don't know where I want to put this, but I don't want to take up much room. But anyway, that's 2.5. And then to turn this into a mixed number, you take 2 times 2, so denominator times the whole number, 2 times 2, which is 4, and then you add your numerator in, and 4 plus 1 would be 5. So then you have 5 over your original denominator of 2, and then there you have it. So we're going to change this to cosecant of theta is equal to 5 over 2. And now you actually have 2 sides of a triangle. Cosecant is the hypotenuse over the opposite side. It's your sine reciprocal, and sine is over h, so cosecant is h over o. You now know 2 out of the 3 sides of your triangle. And we need to find the adjacent side. That's what's missing. So we have 2 out of the 3 sides of a right triangle because trigonometry works with right triangles. If you have 2 out of the 3 sides of a right triangle, you can use the Pythagorean theorem. Now in class, I drew a picture for the first example, the A example. So I guess I'll go ahead and do that again, but you really don't have to. When we get to the B example, I'm not even going to draw a picture. So if you require a picture, then go ahead and draw some random right triangle and take your little theta right here and just put him on the picture in either one of the acute angles. It doesn't matter which one you pick, just pick one and, use it. Pick it and commit. Okay, so I'm up here at the top. I decided to put my theta at the top. I could have put it at the bottom and everything would still work out the same, but I chose the top. So from this position up here, my hypotenuse is across the right angle. This would be the opposite side, and then this would be the adjacent side. Kind of like the other 2 examples or 2 problems we did in example 1. All right, so my hypotenuse is 5. I'll tack a 5 on there. My opposite is 2. I'll put a 2 down at the bottom, and then we're trying to find this missing side here. So now with this visual, you can see that we got 2 out of the 3 sides of a right triangle, and we're going to use the Pythagorean theorem, which is a squared plus b squared equal c squared. Hypotenuse always goes in for the c in the formula. So I didn't even really need a picture to tell me that. I knew over here when I first wrote down my h that 5 right there that I just drew an arrow on, that 5 was definitely going to have to go in for c. So the picture is like totally unnecessary if you don't want to draw it. And then it doesn't matter what leg you put in for a or b. So I'll just put the 2 in for a and leave b the unknown. And then 5 goes in for c. Let's go 1. Let's make it a 2. Okay, so then we have 4 plus b squared is equal to 25. B squared is equal to 21, square root both sides, and then b is equal to root 21. So your adjacent side is root 21. And then I have everything I need to build all of my ratios. I have 1, and now I can find the other 5. So let's do our assembly. Sine of theta, cosine of theta, and then tangent of theta. Alrighty then, sine is over h, so that's going to be 2 over 5. Cosine is a over h, so that's root 21 over 5, and tangent is o over a, so 2 over root 21, and then that has to be rationalized into 2 root 21 over 21. And then we have cosecant, which was given, and then we have secant and cotangent. What? Hang on. Okay, great. Hang on. Okay, so cosecant is the given, so that's 5 over 2, or 2.5. I'm just going to leave it as a fraction. Secant's the reciprocal of cosine. It is h over a, but I'm just going to like flip my cosine fraction to get 5 over root 21, which is 5 root 21 over 21. And then finally we have cotangent, which is just going to be the reciprocal of tangent. I'm going to flip the original one this time because it's easier than flipping the final answer here, the simplified version. The simplified version actually looks more complicated. So I'm going to take that original 2 over root 21 and then write root 21 over 2. Sometimes it is easier to use the original numbers, and sometimes it's easier to flip and use the simplified version. It just depends on the problem. Let's go ahead and finish this example up. So we don't have a fraction over here, so I'm going to take that 6 and turn it into a fraction by putting it over a 1. And now we have a lovely fraction there, which is 2 sides of our triangle. And tangent is it's O over A. And so what we don't have this time is our hypotenuse. And I am not going to draw a triangle. I'm going to go ahead and do this without a triangle. All right, so Pythagorean theorem is a squared plus b squared is equal to c squared. The hypotenuse is going to always go in for C, and we don't actually have anything to sub in. We actually have the A and B legs of our right triangle. So put the 6 and the 1 in either position. Doesn't matter what you make A and what you make B. Your adjacent and opposite are always the legs. And 6 squared is 36. 1 squared is 1. You get 37, and then to solve for C, you're going to square root, and there is our hypotenuse. So we have everything we need to go ahead and build our ratios, aka our function values. So those fractions are actually called your function values. All right, sine from beta, cosine from beta, and then tangent from, what is that? I don't even know what this is. Let's go away. All right, so I can't get rid of that. Anyway, tangent from beta, and let's go ahead and fill in our sine. Sine is O over H. That's 6 over root 37, which is going to be rationalized. You'll get 6 root 37 over 37. Cosine is A over H, so that's 1 over root 37. And rationalized is root 37 over 37. And then finally, tangent is, that was given. That's 6 over 1, or just 6. And now let's find cosecant, secant, and cotangent. All right, cosecant's the reciprocal of sine, so that's root 37 over 6. Secant's the reciprocal of cosine, which is root 37 over 1, or just root 37. And finally, cotangent's the reciprocal of tangent, and I don't see a fraction, but you can always take your whole numbers and put it over 1, and there's your fraction that you can flip. So cotangent's going to be 1 over 6, and then that is it. Oh, um, rationalizing quick before I end this video. I did the rationalizing in my head because I didn't have enough space to do it the long way. But after you rationalize enough of these by showing work, then it's almost like automatic. After you do enough of these problems, if you're actually like doing your homework and going through the process, you won't be able to help yourself. You're going to be rationalizing in your head automatically. But this is some samples of rationalizing. If you have a problem like 2 over root 8, you could rationalize your denominator by multiplying by root 8 over root 8 because you get the square root of 64, which is, take a guess, 8. And then, of course, you have to simplify the 2 over 8 to get 1 over 4, etc., etc. But the point is that you need to create a perfect square that you can square root in your denominator. You do not have to choose like a root 8 in this problem. There's another number that I could use that actually would give me a perfect square that I can square root. I could pick a 2 instead. I can multiply by root 2 over root 2. In my numerator, I get 2 root 2. In the denominator, I get the square root of 16. And the square root of 16 is going to be 4. And then this would simplify further into root 2 over 2. Sorry, this thing is distracting me over here. That sale, I don't know why that's on there. I think it's the program wants me to buy it because I'm using a trial. Anyway, they don't look like the same thing, so I'm going to actually continue to simplify this guy right here, and I will turn that into 1 over 4, and then the root 8 turns into 2 root 2 over 4. That's another story on how you simplify root 8. And then in the end, you get the same overall result. You would get root 2 over 2. Same answer. But by choosing the smaller square root to rationalize with, the overall process is easier. I didn't really tell you how to simplify the square root of 8 and turn it into 2 root 2, but you'd have to do that first in order to fully simplify the problem. So this way right here, second way, on the bottom is way easier. So just multiply your denominators, your radical denominators, by the smallest possible root. That'll give you a perfect square.